Welcome to our course series for system design. I am BitMagicBot, and in this video, we will learn about the CAP theorem in system design. CAP theorem is an important principle in system design that allows developers to focus on key requirements of an application. An application, perfect in all sense, is a myth. There are some areas where it excels, and some areas where it compromises. Practically, it makes sense for an application to be called perfect, if it excels in its key requirements at least. And that's where the CAP theorem comes into the picture. Let's dig into it in detail. In this video, we will learn about what is CAP theorem, history of CAP theorem, the principles of CAP theorem, and how it correlates with NO-SQL databases. Let's look at what CAP theorem is. Have you ever seen an advertisement for a landscaper, house painter, or some other tradesperson that starts with the headline, "Cheap, fast, and good, pick two"? The CAP theorem applies a similar type of logic to distributed systems, namely, that a distributed system can deliver only two of three desired characteristics: consistency, availability, and partition tolerance. The C, A and P in CAP. CouchDB, Cassandra, and DynamoDB are some of the examples of AP databases. MongoDB, HBase and Redis are types of CP storages. RDBMS are examples of CA databases. No system can achieve all the three properties at the same time. A distributed system is a network that stores data on more than one node, physical or virtual machines, at the same time. Because all cloud applications are distributed systems, it's essential to understand the CAP theorem when designing a cloud app, so that you can choose a data management system that delivers the characteristics your application needs most. Let's get to know the history of the CAP theorem. The CAP theorem is also called Brewer's theorem, because it was first advanced by Professor Eric A. Brewer, during a talk he gave on distributed computing in 2000. 2 years later, MIT professor Seth Gilbert and Nancy Lynch published a proof of Brewer's conjecture, and that's where the CAP theorem became an important principle of the system design architecture. Let's take a detailed look at the three distributed system characteristics, to which the CAP theorem refers. Consistency. A system is said to be consistent if all nodes see the same data at the same time. Simply, if we perform a read operation on a consistent system, it should return the value of the most recent write operation. This means that the read operation should cause all nodes to return the same data, that is, the value of the most recent write. Availability. Availability in a distributed system ensures that the system remains operational 100% of the time. Every request gets a non-error response, regardless of the individual state of a node. However, this does not guarantee that the response contains the most recent write. Partition tolerance. This condition states that the system does not fail, regardless of if messages are dropped or delayed between nodes in a system. Partition tolerance has become more of a necessity than an option in distributed systems. It is made possible by sufficiently replicating records across combinations of nodes and networks. Now that we know the principles of the CAP theorem, let's review how it correlates with NoSQL databases. NoSQL databases are ideal for distributed network applications. Unlike their vertically scalable SQL counterparts, NoSQL databases are horizontally scalable and distributed by design. They can rapidly scale across a growing network, consisting of multiple interconnected nodes. Today, NoSQL databases are classified based on the two CAP characteristics they support. CP database. A CP database delivers consistency and partition tolerance at the expense of availability. When a partition occurs between any two nodes, the system has to shut down the non-consistent node, that is, make it unavailable, until the partition is resolved. AP database. An AP database delivers availability and partition tolerance at the expense of consistency. When a partition occurs, all nodes remain available, but those at the wrong end of a partition might return an older version of data than others. When the partition is resolved, the AP databases typically resync the nodes to repair all inconsistencies in the system. CA database. A CA database delivers consistency and availability across all nodes. It can't do this if there is a partition between any two nodes in the system, therefore can't deliver fault tolerance. We listed this CA last for a reason. In a distributed system, partitions can't be avoided. So, while we can discuss a CA distributed database in theory, for all practical purposes, A CA distributed database can exist. However, this doesn't mean you can't have a CA database for your distributed application if you need one. Many relational databases, such as PostgreSQL, deliver consistency and availability, and can be deployed to multiple nodes, using replication. Distributed systems allow us to achieve a level of computing power and availability that was simply not available in the past. Our systems have higher performance, lower latency, and near 100% uptime in data centers that span the entire globe. Understanding the complexity incurred in distributed systems, making the appropriate trade-offs for the task at hand, while applying the principles of CAP Theorem, and selecting the right tool for the job is necessary, as it plays an important role in determining a good system architecture. This is it, we are done with the CAP Theorem. Best of luck and happy designing.